This moment right here might just be one of the most profound in human history, not just for astronomers but for all of us. For the first time ever, we may actually be seeing signs of life on a world beyond Earth. Imagine that. After centuries of looking up at the stars and wondering if we're alone, now we're closer than ever to an answer. And that answer might be coming from a distant exoplanet known as K2-18b, a planet that orbits a red dwarf star located about 120 light-years away from us in the constellation Leo. K2-18b isn't just any exoplanet. It's a super-Earth about 8 times more massive than our own planet. It was first discovered in 2015 by NASA's Kepler Space Telescope. But from the beginning, this world stood out to astrobiologists and astronomers alike. Why? Because K2-18b is located right inside the habitable zone of its star, the region where temperatures are just right for liquid water to exist. That alone made it an intriguing candidate for further study. But what really caught the scientific world's attention was something even more interesting. It might actually be a water world. Yes, a water world. Just picture that for a second. A planet covered by a vast global ocean, possibly teeming with the building blocks of life. So naturally, once the James Webb Space Telescope became fully operational, one of its key missions was to take a closer look at this world. And it did. In 2023, K2-18b burst into headlines around the globe when researchers announced something extraordinary. Observations from the JWST suggested that K2-18b wasn't just in the habitable zone. It might actually be habitable, even hosting an entire global ocean beneath a hydrogen-rich atmosphere. But it didn't stop there. That same year, the research team detected weak but tantalizing signs of a chemical called dimethyl sulfide, or DMS. Now here's where it gets really exciting. On Earth, DMS is produced almost exclusively by living organisms, primarily marine phytoplankton. So when astronomers found traces of DMS in the atmosphere of K2-18b, the implications were stunning. Suddenly, the possibility wasn't just that the planet could support life. It might already have life. But one observation wasn't enough. Scientists knew they needed more data, more confirmation, more scrutiny. So the research continued. And now, after 2 full years of follow-up observations and rigorous analysis, the James Webb Space Telescope has revealed something astonishing. Its instruments have detected not just DMS again, but also another molecule, dimethyl disulfide, or DMDS. Both of these compounds are considered strong biomarkers. And here's the kicker. On Earth, both are almost always associated with biological activity. In this video, we're going to break down exactly what the JWST found in the atmosphere of K2-18b, and we'll hear directly from Dr. Madhusudhan, the lead researcher behind this potentially game-changing discovery. Dr. Madhusudhan explained that his team used a method called transit spectroscopy to analyze the atmosphere of the exoplanet. Here's how it works. When a planet passes in front of its host star, from our point of view, a portion of the starlight filters through the planet's atmosphere before it reaches our telescopes. The molecules in that atmosphere absorb specific wavelengths of light. By comparing the starlight when the planet is in front of the star to when it's not, scientists can determine which molecules are present in the planet's skies. It's like identifying fingerprints left behind by invisible gases. Back in 2023, the first observation hinted at DMS in the planet's atmosphere, but the evidence was faint and uncertain. It came from a specific wavelength range between 1 and 5 microns, using one of JWST's instruments. But that wasn't enough to convince the scientific community. So, the team turned the telescope back toward K2-18b with a different instrument and a new wavelength range. This time the data came back far more compelling. The signal for DMS was significantly stronger, measured at a confidence level of 3 sigma, which is a meaningful statistical milestone in science. But that wasn't all. Alongside dimethyl sulfide, the team also detected dimethyl disulfide. Like DMS, DMDS is also a strong biomarker and has long been predicted to be a sign of biological activity, especially in planets with hydrogen-rich atmospheres like K2-18b. What made this so compelling was that both compounds appeared in the data with a level of significance that couldn't be easily dismissed. And no matter how many times the team reanalyzed the numbers, the signal remained consistent. It wasn't a fluke. The data was telling a clear story. These molecules were present in the planet's atmosphere. What's even more mind-blowing is the abundance of these molecules. The measurements suggest that there could be thousands of times more dimethyl sulfide on K2-18b than there is on Earth. Think about that. If true, this might mean the oceanic environment of the exoplanet is flourishing with microbial life. Imagine entire ecosystems beneath those alien waves, unseen and unimaginable but active nonetheless. Of course, this raises the biggest question of all. Does this confirm the existence of life beyond Earth? Is K2-18b actually inhabited? According to Dr. Madhusudhan, this is one of the most important questions humanity has ever asked. For him, both as a scientist and as a human being, this moment is deeply emotional. Because we might be witnessing something that was once thought to be impossible, proof of life in another part of the cosmos. And even if these molecules turn out not to be biological in origin, it's still a breakthrough. Why? Because it would point to previously unknown chemical processes happening in the atmosphere of a potentially habitable world. That alone would be a revolutionary discovery, something that could reshape our understanding of chemistry, planetary science, and the very nature of life. In any case, this discovery is transformational. It shifts our perspective as a species. It nudges us closer to answering the age-old question, are we alone in the universe? And yet, not every scientist is ready to celebrate. Some experts remain skeptical of the biological interpretation. They argue that while K2-18b may have a hydrogen atmosphere and possibly even a liquid water ocean, that doesn't automatically mean it's home to life. These characteristics simply make the planet a candidate for habitability, not a confirmed biosphere. In their view, caution is still warranted. Adding to that, the telescope also detected the presence of carbon dioxide and methane, two other molecules often linked to biological activity. However, both gases can also be produced by entirely non-biological processes. Take Mars, for example. NASA's Curiosity rover has detected methane emissions on the red planet, especially near Gale Crater. Yet, to this day, scientists haven't found compelling evidence for current or ancient life on Mars. It's possible that similar abiotic processes are at play on K2-18b, creating gases like methane and DMS through geological or chemical interactions rather than biological ones. In fact, some researchers point out that dimethyl sulfide isn't always a sign of life. There's a recent study, still in its preliminary phase, that suggests DMS might even be produced by non-living processes on comets. In particular, Comet 67P was analyzed, and the data hinted at possible traces of DMS. If that's the case, it introduces a huge variable into how we interpret biomarkers. After all, what we consider a biosignature on Earth may not hold the same meaning on an entirely different planet, with different geology, chemistry, and environmental conditions. So, how do we interpret these findings from the James Webb Space Telescope? How do we determine whether we're seeing signs of life or just unusual but lifeless chemistry? To answer these questions, a team of researchers from NASA's Ames Research Center and the University of Washington developed a series of advanced models. These models simulate two broad categories of planets: rocky worlds with surface oceans, some with life, some without, and gaseous planets with thick atmospheres, lacking any surface or biosphere. They then applied these models to the observational data from K2-18b to see which best fit the evidence. The models accounted for both the photochemistry and climate of the planet. Photochemistry refers to chemical reactions triggered by light from the host star, which can drastically influence what molecules appear in the atmosphere. For instance, ultraviolet light can break apart certain compounds or create entirely new ones. The researchers also simulated how different kinds of planetary climates, whether warm and oceanic or cool and cloud-covered, would influence the atmospheric signatures detected by JWST. It was a deep dive into the possible realities of this distant world, using the best tools modern science has to offer. After running the simulations, the results leaned in one direction. The team found that K2-18b is unlikely to be a lifeless ocean world. Why? Because such a planet wouldn't be able to sustain the level of methane observed in the atmosphere. Methane, especially in large quantities, tends to be unstable over time unless there's a continuous source replenishing it. On Earth, that source is often biological. The same principle might apply to K2-18b. Without life or some other active process, the observed atmospheric chemistry just doesn't make sense. And that's what makes this finding so provocative. So, based on all these initial observations, the planet seems like it could be a water world, possibly with microbial life. This has led to the idea that simple, methane-producing organisms might be responsible for the methane we're detecting in the planet's atmosphere. That's exciting, isn't it? But hold on. While this theory has sparked a lot of hope, scientists are also weighing another explanation that doesn't require life at all. A lifeless, gas-rich exoplanet model still fits the data reasonably well and may actually offer fewer challenges when trying to explain the observed atmospheric features. See, the ocean world model is full of promise, but it also comes with some serious scientific hurdles. It not only assumes the existence of life to explain the methane, but it also has a hard time explaining how the surface temperature could stay cool enough for an ocean to exist. This is where the idea of a runaway greenhouse effect becomes a major concern. If that effect is present, the planet could be far too hot to support life in any form, even microscopic. So, the research team recommends that when searching for life on exoplanets, we should first check if the planet is actually cool enough to even have an ocean. But don't let this discourage you just yet. This isn't the final verdict on K2-18b. The truth is, when scientists looked at the planet's atmospheric spectrum, they found features that don't perfectly align with either theory, neither the lively ocean world nor the lifeless gas planet. Both models seem to be missing pieces of the puzzle. And remember, this entire analysis is based on just 2 observations. That's a small dataset. So, this should be seen as an early demonstration of what the James Webb Space Telescope can do in exploring potentially habitable exoplanets. As we gather more data, the picture could become a lot clearer. For instance, if future observations detect ammonia, that could indicate a gaseous, uninhabitable world. But if scientists detect dimethyl sulfide, a compound that, on Earth, is only produced by life, it could drastically shift the narrative in favor of an inhabited ocean world. So, as of now, the mystery remains open, and the quest to find habitable worlds continues. What we need is more data, more time, and more refined instruments to tell us whether we're truly looking at a home for alien life. Even if we confirm that K2-18b is an ocean world with microbial life, there's still the issue of distance. This planet is located 124 light-years from Earth. That might not sound like much in cosmic terms, but using our current rocket propulsion technology, it would take us over 1 million years to reach it. That's just not practical for human exploration. But what if we found something much closer? What if there was a planet just dozens of light-years away with a cloudy atmosphere and a water ocean half the size of the Atlantic? Sounds more exciting already, doesn't it? Well, that excitement might just be justified. The James Webb Space Telescope may have found one of the most promising signs yet of a potentially habitable planet beyond our solar system. Discovered back in 2017, LHS 1140b is an exoplanet orbiting within the habitable zone of its red dwarf star, LHS 1140. What makes this find even more thrilling is its proximity. This exoplanet is only 40 light-years away. That's a cosmic neighbor compared to other candidates. Originally, scientists thought it might be a mini-Neptune-type gas planet, but newer data has flipped that assumption on its head. When the Webb telescope focused on this planet in December of last year, and combined its findings with older data from Hubble and Spitzer, a much clearer picture began to emerge. Rather than being a gas dwarf, LHS 1140b might be a rocky world. Even more surprising? It appears to be sitting comfortably in the star's habitable zone and may even have a nitrogen-rich atmosphere. This is huge. A nitrogen-rich atmosphere increases the chance of retaining liquid water, which is one of the key ingredients for life as we know it. Now here's the kicker. Based on Webb's observations, scientists estimate that somewhere between 10% and 20% of the planet's total mass could be composed of liquid water. That paints an incredibly vivid picture of what the planet might look like. Imagine a giant snowball planet, with its rotation locked to its star, meaning one side always faces the sun while the other remains in permanent darkness. The side facing the star would be warm enough to melt part of the surface, creating a permanent liquid ocean, while the dark side would stay frozen. You might be thinking this sounds like just another super-Earth we've heard about before, but LHS 1140b is different. Take the famous TRAPPIST-1 system, for example. It also has several Earth-sized planets in its habitable zone, but its host star is extremely active. That stellar activity interferes with observations and makes it hard to tell if those planets are actually habitable. But with LHS 1140b, the star it orbits is much quieter. It's less likely to produce star spots and other noise that can confuse our instruments, making it easier to get clear atmospheric data. Ryan McDonald from NASA, who helped analyze the planet's atmosphere, pointed out that this quieter star gives us a much better shot at accurate readings. According to current climate models, if LHS 1140b indeed has an atmosphere like Earth's, it would be what scientists call a snowball planet, with a central ocean resembling a bullseye roughly 4,000 kilometers in diameter. Even more astonishing, the temperature of this ocean could be a mild and comfortable 20 degrees Celsius. That's practically room temperature, on a planet outside our solar system. So, what's the plan moving forward? The scientific team has now put in a request for additional observations using the Webb telescope. These will focus on transits and eclipses, aiming to detect the presence of carbon dioxide in the planet's atmosphere. That would be a big clue supporting the existence of liquid water. The catch. LHS 1140b is only visible to the James Webb Telescope a limited number of times each year, no more than 8 visits annually. So it'll take several years of patient data collection to build a complete profile of this mysterious world. But even with those limitations, this is one of the most promising leads we've ever had in the hunt for habitable planets beyond Earth. The possibility of an Earth-like world with an ocean, an atmosphere, and a comfortable temperature just 40 light-years away opens up incredible opportunities. Maybe not for us to visit anytime soon, but certainly for future generations armed with better technology. What do you think about this cosmic discovery? Could LHS 1140b be our future second home, or even host simple alien life? If you're fascinated by these discoveries as much as we are, let us know in the comments below. And if you enjoy this kind of space exploration content, consider supporting our channel by becoming a member. Your support helps us keep digging into the universe's greatest mysteries. And don't forget to subscribe to Mittar TV because remember, this is your space.